So 2.5 part 2.
Good morning, everyone.
Okay, so let's go ahead and look at this. Yesterday we were looking at the long division, right? And we were looking at synthetic division. It turns out you can use this synthetic idea to find some of the zeros of a polynomial. So we're going to start to look into that. So this is the essential question we'll answer today. If you know 1 0 of the polynomial, how can you find another or all the others? So we'll kind of look into that. Now, when we've been doing long division, we've been having a remainder almost every single problem, right? Well, what happens if the remainder is actually 0? And that's what we're going to look at today. What it means is that it divides n evenly. And it also means that you have a 0 of the polynomial. What we're looking at is like when you do synthetic, we'll be doing this synthetic division here in just a second. If you were doing synthetic division and you set up a box like this and you have like maybe 5 and then you have all these numbers across the top like 1, 7, -2, 3, 4, and you work along and you get 0 here. What that means is that this original number was a factor. You know how like we try to factor this? We want to do this. We would like to factor this cubic polynomial. We'd like to factor it.
You'll find the 0 of the...
Yeah, well, we can imagine this is 0 for a second also. That would give us the zeros. But if we come along here and get a 0, then this number was a factor. So what we need to do is write it as a factor. So what we would do in this case, we'd write x minus 5. Now you might say, well, why are we using positive 5 over here? Well, remember, if we're doing zeros, like if we're doing 0, what value of x would this be to give you a 0? You'd say, well, that would have to be x equals 5. Does that make sense? So if you're using synthetic substitution or whatever, synthetic division, whichever you want to call it, and you do this little algorithm here where you do this zigzag pattern and you get a 0 over here, it means that this was a factor of the original polynomial. So here's the thing to remember. It's kind of like synthetic division. If this sign here is positive, then the factor is going to be negative. I mean, you write it with a negative. So let me show you what we're going to do here. We're going to try and find all the factors here of this polynomial. And we're going to start off by knowing that this one is. So basically what we know on this particular problem is we have this little hint. We have f of x and we're trying to factor it, and someone gives us a hint and they say, okay, well, x plus 2 is a factor. Okay, well, can we figure out these two then? Can we figure out how this factors further? Because sometimes factoring by grouping doesn't work. I mean, if you try factoring by grouping on this one, what would we do? Well, we could take out an x squared, and then what would we have? We would have an x minus 4. Okay, but look up here. You can't get an x minus 4 here for the second factor. What number would be out in front? You can't get the 28. If you put 28 there, then you'd have 28 times 4. And see, so you see this one doesn't factor by grouping. So most of the time trinomials, or not trinomials, these cubic equations are difficult to factor. And so we're giving you a hint here, and we're going to say, hey, this is one of the factors, but can we go ahead, if we know that information, can we figure out the other two factors that go here? Can we figure out this one, and this one. Now, this idea that we're doing today is kind of builds up to an idea that we would cover in 2.6, but we're not going to cover 2.6. So we'll use this idea. I'm going to show you how this problem works and stuff like that. Okay, so just follow along. What I'd recommend is just pay 100% attention to what I'm doing. Don't try to take any notes right now. Try to understand the algorithm, okay? This is where you got to focus on the algorithm. Okay, so if this is a factor, what you're going to do is you're going to set up your box again. You're going to do some synthetic division again, or synthetic substitution. And so you write down 3 minus 4 minus 28 minus 16. And I want you to imagine if you were setting this factor equal to 0, you would set this equal to 0, right? And then you would solve for x, and you get x is equal to negative 2, right? That's the number you use here. Okay, because I can tell you the number one mistake here is that they used the wrong number. They put 2 in here, and they should use negative 2. Okay, so this problem that we're doing where we're finding the factors, it's very similar to the synthetic division. Remember, on synthetic division we always change the sign, but we change the sign for that one to take care of all the subtraction steps. So this is changing the sign for a different reason, because this is a factor now. Okay, so now we set negative 2 here like this, and we do our synthetic division. We just zigzag through. So we drop down the 3, and we multiply this, we get negative 6. And then this gives us negative 10. Okay. And then we keep zigzagging. This gives us a positive 20 here, right? It's positive. And then this gives us negative 8. And if you do negative 8 times negative 2, that gives us a positive 16. And now you'll notice you get a 0. So indeed, x plus 2 is a factor. So it went in evenly. Whenever you get a remainder of 0, it should remind you what happens when you're doing long division. And let's say you go 2 and you're going into 4, 0, 8. Alright? Well, 2 goes into 4 twice. You can put a 4 here, and then you get a 0, bring down the 0 again. And then 2 doesn't go into 0, so you put a 0 here. And then you bring down the next number, you get an 8 here. And 2 goes into 8 4 times, and it goes in evenly. You get 8 here. And you get 0 here, right? And then we say remainder 0, right? Well, in this case, we don't have a remainder, right? And so we don't put the remainder there. It went in evenly. Well, that's exactly what happened here. This polynomial here, this binomial, went in here evenly. And what it means is that this is a factor. So let me write down what the next step is. What we do know is that 3x cubed minus 4x squared minus 28x minus 16, we know something about this. We know that it's equal to x plus 2 times something else. Now that something else we are going to want to factor further. So that something else though is right here. So that's where it's helpful if we do the synthetic substitution method that we were doing yesterday. We can find out what the other factor is right now. Remember, how do we figure out this? If you were to take the x minus 2 and you were to divide here by x minus 2, wouldn't this x like cancel off with one of those x's up there? It'd lower the degree by 1, right? So this is going to be 3x squared. This is going to be 10x, and then that's going to be 8. So this factor here is 3x squared minus 10x minus 8. Okay? Well, you guys know how to factor this, right? We could either factor this by the guess and check method, or we could factor it by the AC method. Now, I kind of like the guess and check method. I think it's faster. But for this first problem, I will demonstrate both ways. So, remember what we do? This factor here takes the first slot and the third slot. And there's not a whole lot of options here, right? We have 3x times x, right? So I know they're going to take the first and third slots. So I'm going to put a 3x here. I'm going to put the other x here. Okay? Now what I have to do is make some clever guessing. This is called the guess and check method, remember? I need to guess correctly what goes in here and here. And those factors that go there come from the negative 8. And so I'm going to make a little list real quick. I can have like 1 times 8, and I can have like 2 times 4, right? But I got to combine these two with these two somehow, and my goal is to get negative 10 somehow. And I'm going to have to subtract because there's a negative sign in here. So, for example, if I take the 3x, and if I combine it with this 4, right there, I get 12x, right? That would give me the 12x. And then if I take this x, and I combine it with the 2, I get 2x. Now my goal is to get 10, negative 10. So if I make that one negative, this one positive, I've achieved my goal of getting negative 10x. So I know this is the combination that works with this combination. And now which number went with the 3? Remember, the inside two go together and the outside two go together. Let me erase that, make it neater. Okay, so here's the little trick. You have to remember these two go together, the outside two go together. So the 3 went with the 4. The x went with the 2. And which one's negative? We wanted this one to be negative, right? So the 3 went with the 4, so that makes that one negative, makes this one positive. So we factored this, and now this is the third factor. X plus 2. So there we have our polynomial. It's factored now. Alright, well, wasn't that fun? Okay, so what we need to do is about 4 or 5 more of these so that you get all the process down on how to do it. And then I think you'll be able to do this. Huh? Yeah, let's do a couple more though. Okay, so as you might imagine, factoring a trinomial, not a trinomial, a cubic equation is a little bit more difficult than the trinomials that we did in chapter 1. And if you can't do factoring by grouping, we got to do it this way. Okay, so thank goodness someone told us one of the factors that made our work a lot easier, because then we were able to factor this quadratic on our own. How about the AC method? Do you guys remember the AC method? Okay, so let me just show you how we would have done it if we were doing the AC method. If we were doing the AC method up here, we wouldn't have used the guess and check method. We would have done a few other steps instead. Okay, so the AC method, just to review that, you would have started out by multiplying those two together, and you would have had negative 24. And then you would have said, well, what two factors of negative 24 give me negative 10 when added? And hopefully you would have said negative 12 times a positive 2. And then you would have rewritten this part as 3x squared minus 12x plus 2x minus 8. And then we would have factored by grouping. And so then we would have taken out, let's see, out of these two terms we would have taken out a 3x, and we would have ended up with x minus 4. And always when you're doing the AC method, you're going to get the same factor twice. So we could go ahead and write it down twice. And you can figure out this number here. And it looks like that's going to be a 2. And then you can see the final step would have been 3x plus 2 and x minus 4. And so then this is the first factor, x plus 2. So the AC method would have given you the same answer. And whatever method you like best, you can go with. But this is equal to our original function f of x. And now it's factored. Okay, so I will go ahead and show you another example, and then we could go ahead and start working on our book assignment. Alright, so here's, this time we're told that x minus 4 is a factor. So again, what we're trying to do is to factor this. And currently we know that x minus 4 is a factor. But what we'd like to do is factor it further, like that. So we're going to figure out what's this one and what's this one. Well, to do that, I'm going to do some synthetic division. So I'm going to create my little box right here, and the number I'm going to use is not this one, because what I'm thinking in my head is if that is a factor, then it's also a 0 of the polynomial. So I'm thinking x minus 4 is equal to 0, and I'm thinking, well, that would mean then that x is equal to 4. And so that's the number I'm going to use here, 4. Ooh, can't see that very well. Now I can see it better, right? Yeah? Okay, so then I'm going to use these polynomials. So we're going to use these coefficients. 1, negative 6, 5, and 12. Now what do I be knowing already? I know that this is a 0, because this is a factor. That only happens if that's a factor. So after I get through my zigzag, that better be a 0. Okay, so let's see if that happens. We drop a 1, and we get a 4, get negative 2, get negative 8, get negative 3, and 4 times negative 3, negative 12. And that, of course, is 0. Okay, so just as we did on the last problem, this factor right here, we know it's going to be this one. This is like 1x squared, 2x minus 3. So x squared minus, use a different color? Sorry. X squared minus 2 minus 2x minus 3. Is that okay? Everyone can see now? Okay, so now here's the thing. This is a trinomial now. We should be all experts at factoring trinomials, right? And this one's easier than the previous one, right? The previous one we used the guess and check method. Now this one's even easier than that one. Because the coefficient right here is a 1. Coefficient equal to 1 in front of the x squared term is much easier. Okay, so all we're doing now this time is just looking for two factors of 3 that give us negative 2. How about negative 3 times a positive 1? Would that work? And so that would give us x minus 3 and x plus 1. And now we have this completely factored. Okay, we've completely factored it. Okay, so I think maybe I'll just do maybe one more. Alright, this one's it's the same type of problem. Hold up, I got it. get the phone this way. So sometimes they write the problem this way. It's the same type of problem. Now, make sure you understand this notation here. This is function notation. So what it's saying is f of x is equal to 0. Now, what they just gave you are two coordinates. And what they gave you was an x and a y. Now remember, f of x is the same thing as y. So what they're saying is y is equal to 0. Okay? So that means the y coordinate is 0. And the number that they're putting in right here, that's x. You see? That's the x. So this means this is x. X is equal to negative 2. You see? Does that make sense? So they basically gave you some coordinates here. Now, they're saying find all the zeros. Well, if negative 2 was a 0, look, our goal here is to factor this again. We're supposed to find 3 factors. Okay? And they tell you that f of negative 2 is a 0. Well, what's that mean then? It means x plus 2 was a factor. Does that make sense? Because remember what we'd do if this were set equal to 0? What would we do? We'd set each one of these. This will give us x is equal to negative 2, you see? And that's what this says. F of negative 2 is equal to 0. You see? That would be a 0 over here. Well, what we're after are the other two factors again. So this problem is a slight variation of the previous problem. They're just giving this information here. But you need to realize that that's the same thing of saying that this is one of those factors. And then we're still after these other two factors. And the way we do it again is by using synthetic division again. So let's go ahead and I'll show you that on a little slightly bigger screen here. So I'll walk you through that procedure again. Okay, so we know then that x plus 2 is a factor of this cubic equation. And what we're going to want to do is factor it further. So we're after that. And the way we figure out that is, remember, since this is x plus 2, we're going to use a minus 2 here. And then we're going to use these coefficients. There's a 1 here. So a 1, a 2. Yeah.
Is the factor always going to be a negative 2?
Is it? It's going to. The factor is not always going to be.
I thought you like flip it around, so it would have been plus positive 2 that you can factor out. Multiplying it by.
Say it one more time.
You know how the negative 2 is on there?
Yeah.
You would have to flip the signs around to get log.
Right. The factor would be this, though. You see, this is a slight variation of the previous problem. All I'm saying is that this information tells you the coordinates, tells you the y coordinate is 0 and this is negative 2. But if they wrote it as a factor, it would be written like this. Because they're telling you that it's equal to 0, you see? That's switch the color. So they're telling you that this factor here is a 0. Okay? And how would that be equal to 0 if this were factored? Well, you'd have to get negative 2. Okay? And that's what they're trying to tell you up here. Yeah? You're changing school?
Yeah.
What happened? You're doing better this year. What'd you have in my class? I'll just make it a C. Alright. Fair enough. Where are you going? Vegas? Lost wages. Well, see you later. Take care, buddy. Okay, so back to our problem. So do you understand now why we're using negative 2 up there? So So anyhow, we're gonna go through. You guys ready? So we zigzag through again, and by the way, I know this is going to be a 0, right? I know there's a 0 there, right? It better work out that way, because we were told that this is a factor over there. Okay, so if we drop the 1, we get -2 here, right? And we get 0 here. -2 times 0, 0. So then we get -9 here. And we get negative times a negative is a positive 18. And it's a positive 18, so sure enough we get 0. So what do we get here? This, remember, if you divided this through by x plus 2, you're going to lower the degree by 1, right? So this is going to be like x squared. This would be like 0x. And this would be -9. So what goes in here would be x squared minus 9. Now the question as far as factoring goes, is this complete? Well, no, this is a difference of 2 squares. We know how that factors, right? We're going to get x plus 2, and then we're going to have x minus 3, x plus 3. And now this is completely factored. Now in this case they're asking what are the other zeros? So if this were equal to 0, what would that mean? Well, it would mean this one is the one that we just talked about already. That one is x equals -2. Okay? That one was given to us right here. This one is x equals positive 3. And this one, x is equal to -3. So you found 3 of the zeros. And that's the most you can have when you have a cubic equation. See, the degree of the polynomial is 3. So basically it means you're going to have 3 zeros. And sometimes those zeros are the same zeros, but most of the time they're different. Okay, so this problem here is a slight variation of the previous two that we just did. Okay, so that kind of wraps up the question. So you can now work on your book assignment and finish up part 2. You've got a full half hour, 25 minutes right now to work on it.
Ooh, Jackie strikes with the flesh of the kidneys.